In this video, we'll be converting galvanometer to ammeter using shunt. I'll be converting galvanometer to voltmeter using multiplier. Alright, galvanometer measures small current. Now, when we want to use it to measure higher current, we need to convert it. Okay, we need to apply a shunt. So let's look at the circuit. So in this question, we are told that the galvanometer has a resistance of 50 ohms and it gives a full-scale deflection when a current of 2 milliamps passes through it. So this is the maximum current the galvanometer can withstand, and we want to use it to measure a current of 5 ampere. That is way bigger than what it can withstand. So we are asked to calculate the value of shunt resistance that is required to solve this problem. So this is the approach. We are going to connect the galvanometer this way. When this 5 ampere that we want to measure, when it gets here, we provide an alternative pathway for it in this fashion, so that the 2 milliamps goes to the galvanometer. So this goes to the galvanometer, that is 0.002 ampere, which is what it can withstand. Remember, 5 is coming here. So 0.002 will go to the galvanometer, then SS should come down and follow the shunt. So we're going to say 5 minus 0.002, and that is 4.998. So simply understand how shunt works as this. It diverts the excess current coming in to its own direction. So the maximum that the galvanometer can withstand, which is 2 milliamps, will just go to the galvanometer. Then the SS will now follow the other pathway. Okay, then it joins this here and continues its motion. So this is R here. So we are told that this galvanometer has a resistance of 50 ohms. So let's call that the resistance of the galvanometer. Let's call that RG, which is 50 ohms. This current, we'll call it IG, that's the current of the galvanometer. Then this 4.99, let's call it IS, that is the current of the shunt. Then this is, of course, the resistance of the shunt. Now, take note of this. This node and this node are in parallel. That means this galvanometer and this shunt are in parallel. That means the voltage across them is the same. So the voltage across the galvanometer is the same as the voltage across the shunt because they are connected in parallel. So we are going to say that the voltage across the galvanometer should be equal to the voltage across the shunt, which is this, because they are connected in parallel. Alright, from Ohm's law, voltage is current times resistance. So VG should be IG, then RG. This G here is just telling you that you're working on a galvanometer current and galvanometer resistance. Then VS will be IS, then RS. Remember, we are looking for the shunt resistance, RS. So I'm going to make RS the subject. So RS will be IG RG upon IS. So RS will be IG, current of galvanometer, which is 0.002, multiplied by RG, which is 50, the resistance of the galvanometer, then divided by IS, current of the shunt, that is 4.998. So RS will be 0.002 multiplied 50 divided by 4.998. That gives us 0.02. That gives us 0.02 ohms. That gives us 0.02 ohms. That is a small value of resistance. and that is valid because for this 4.998 ampere of current to follow this path, it means the resistance here should be lesser than that is here, and here we have 50 ohms, so we have to provide lesser resistance here, which we have gotten as 0.02 ohms for this amount of current to follow this. So we need low resistance for us to have higher current flowing through this. So this is how you convert a galvanometer to an ammeter to read a higher current, even though it can only read just this small value here. So you apply a shunt to divert the excess of the current to another direction like that. So that is how we convert a galvanometer to an ammeter capable of reading a higher current. All right, this is the second question here. With it, we'll explain how galvanometer can be converted to voltmeter capable of reading higher voltage. So let's look at this example. A galvanometer has a resistance of 100 ohms. So this is the resistance of the galvanometer and gives a full-scale deflection when a current of 1 milliamps flows through it. Calculate the value of the resistance that must be connected in series. So let's highlight this series with the galvanometer so that I can measure up to 10 volts. So this galvanometer, want to convert it to a voltmeter that can measure 10 volts, and that resistance that is required has to be in series. Let's look at the diagram. So this is the galvanometer here. So we need to connect a resistor in series to it, okay, from this point to this. So we are told that this galvanometer gives full-scale deflection when a current of 1 milliamps flows through it. So the current here, since it's series connection, the same current passes through them. So just say I equals 1 milliamps, and that gives us 0.001 amps flowing through it. And the resistance of this galvanometer, which is going to be Rg, is going to be 100 ohms, as we are given here as the resistance of the galvanometer. Now in this shunt, we are not given the resistance. Of course, that's what we are looking for. Sorry, in the multiplier, we are looking for this resistance that is required. Now, of course, the same current, since it's series, the same current passes through them. I want to use them to measure 10 volts. So what we say is this: the voltage across this galvanometer, let's call it V1. The voltage across this multiplier, let's call it V2. Then we want to measure all together with them 10 volts. So this 10 volts should be V1 plus V2. Like, we want to use them to measure 10 volts, and their individual voltages is V1 and V2. So 10 volts should be equal to V1 plus V2. So 10, I'll drop this V. 10 should be equal to, now V1 is going to be IRG, which is going to be 0.001 multiplied by Rg, which is 100, okay, plus V2. The same current passes through series arrangement, so it's going to still be 0.001 multiplied by R. That's the resistance that we are looking for. Okay, so this is going to be 10 equal to, when I do this, I'm going to have 0.1 plus 0.001 R. I'll take this here. I have 10 minus 0.1 equal to 0.001 R. This will give me 9.9 equals 0.001 R. That implies that R is 9.9 divided by 0.001. So the resistance needed to do that will be 9.9 divided by 0.001. That gives us 9,900 ohms. That is 9900 ohms. So this is the resistance that is needed for this galvanometer to be able to measure up to 10 volts. We have to apply 9,900 ohms.